Today we'll talk about a technique for finding the determinant of a matrix called reduction to triangular form. We're going to let A be this 4 by 4 matrix. We definitely do not want to use the definition to find the determinant of A. That's because the definition requires us to figure out 24 different permutations and their signs and write out the long form. And then we'd have to plug in numbers because at this point that's the only technique we know for calculating a determinant. So instead what we'll do is we'll row reduce A until it's in triangular form. And so here's A, and as we do each of these row operations, we have a theorem about the properties of the determinant that keeps track of what happens to the determinant as we do different row operations. So let's row reduce. Alright, we take row 2 plus row 3 to row 3, and whoops, as usual I have a typo. Let's make that negative row 2 to row plus row 3 goes to row 3. Okay, now let's take negative 2 row 2 plus row 1 to row 1. Alright, we've done that now. Then we'll take negative row 1 to plus row 3 to row 3. Okay, and so now I've got this thing, I can kind of see that I'm almost done. I need to switch around some rows. So we'll take row 3 and row 4 and swap them, and we'll take row 1 and row 2 and swap them. And now I have a triangular matrix, but I don't know, I know that I can divide row 3 by 2 if I want to, so let's do that. Mostly because I don't have an elementary row operation of that type and I want to sneak one in here. Alright, so 1/2 row 3 to row 3. Alright, here we have a new matrix. I'm going to call it B, and the determinant of B is the product of the diagonal, because it's triangular, which is 2. Alright, I'm going to recapture our row operations that we've done here. So these were all the row operations that we did to A to get B. Now, the first 3 row operations are of the type where I add some scalar multiple of a row to another row, and those do not change the determinant at all. So the determinant of B so far is 1 times 1 times 1 times whatever from the other row operations times the determinant of A. The next 2 row operations, R3 swapped with R4 and R1 swapped with R2, are going to both give me a factor of -1. Alright, and then the final thing, I scaled a row by 1/2, so I get a factor of 1/2, and all of that is multiplied by the determinant of the original matrix. Of course, the determinant of A is what I'm looking for, so let's, well, first of all, let's multiply all that junk in the front together. We get 1/2, and that means that the determinant of A is 2 times B. The determinant of B was 2, so we find that the determinant of A is 4. Now, I'm always a little bit nervous when I've done a calculation because, as you've seen in class, my arithmetic is terrible. I popped this into Wolfram Alpha and verified that my answer was correct. Alright, there you have it. This is reduction to triangular form.